So today we're going to look at a review of the parent functions we've been talking about for this unit. And then we're going to look into transformations, which is just movement of the parent functions. So we've talked about how to make your t-table and plug in your values of your t-table into your equations. So let's look at this first function. This first function is f of x equals x. Remember, f of x is just a fancy way to say y. So when you plug in your x values into the equation for the x value, we have y equals x. So when you plug in -1, you're going to get -1 for your y value. You'll get 0 when you plug in 0, and when you plug in 1, you'll get 1. So graph your ordered pairs, and connect them to make a line. And this is going to be our linear function. Okay. Number 2 is y equals x squared. So we're going to plug in -2 into x squared, and -2 times -2 is going to be 4. -1 squared is 1. 0 squared is 0. 1 squared is 1, and +2 squared is 4. So we're going to graph these ordered pairs. And you get a U-shaped graph, and that is our parabola. F of x equals x cubed. So we're going to take -2 and cube it. So that's -2 times -2 times -2, which is positive -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. And 2 cubed is 8. Okay, graph those ordered pairs. And we have a graph that kind of takes a turn at the origin. Kind of looks like a John Travolta doing the twist. So we'll kind of refer to that as the John Travolta if you need a way to remember that. Number 4, f of x equals 5. Now there's no x value to plug in for this equation, so all of your y values are going to end up being 5, no matter what your x value is. So when you go and graph these, you're going to get your constant equation. That's your constant function. Over here, we've got to name this one. This one, because of our cubed root, is going to be our cubic function. All right, so now we're ready for number 5. Got that misnumbered. Number 5, f of x equals the absolute value of x. So remember, the absolute value sign is going to negate any signs within the absolute value bar. So if we plug in a -2, it takes away the negative, and it becomes +2 for its absolute value. -1 becomes +1, 0 is 0, +1 is 1, and +2 is 2. Okay, graph your ordered pairs. And this is going to make your absolute value graph. Kind of looks like a V. Think of V for value. So that's your absolute value graph. Number 6. What do you think this one's going to be called? It's our square root function because of the square root sign. And as you plug in your t-table in this one, we're going to use 0, 1, and 4 because those are perfect squares and they're going to be easier to graph. So the square root of 0 is 0, square root of 1 is 1, and square root of 4 is 2. So we're going to graph those. And we get a graph that shoots out to the right. We're not going to use any negative numbers because we can't put a negative underneath the square root sign because those produce imaginary numbers, and we're not going to use those right now. this is really number 7. So let's look at number 7 now. 1 over x. If we rearrange this equation and we write it as y equals 1 over x, and then we multiply both sides by x to get rid of this fraction, that gives us x times y equals 1. So now we want to think of two numbers that are inverses of each other that are going to multiply together to make 1. So we know that 1 times 1 is 1, and 1/2 times 2, because remember 2 is reciprocal of 1/2. 1/2 times 2 is going to give us 1. So 2 times 1/2 will also give us 1. And then our negatives, negative times negative is a positive. So we want negative 1, and negative 2, and negative 1/2. And this problem is actually going to have some asymptotes. And those are a line that the curve approaches but never actually crosses. So your axis, your x and y axis, are going to be your asymptotes in this problem. We've talked about those earlier in this chapter. So now let's go ahead and graph our ordered pairs. Remember, they're not going to cross our asymptotes, they're just going to get really close to them. So this one gives us a split graph, and this is going to be our inverse graph, our inverse function. And then our last parent function is going to be y equals the cube root of x. So what do you think this one's going to be? This is our cube root function. And notice again, we've changed up our t-table this time to fit into the cube roots. We want perfect cubes so that we're able to have numbers that are easier to graph. So the cube root of negative 8 is going to be negative 2. The cube root of negative 1 is negative 1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 2. So if we graph these, you're going to end up with another kind of twist here. To me, this one reminds me of a surf, of the ocean. So it kind of looks like a surfer. All right, so those are our basic parent graphs. So make sure you get those down. And now let's look at some transformations. Transformations is just movements of these parent graphs. So once you have these parent t-tables done, you don't have to redo those. You can refer back to those once you've created the first one for your test, and when you're making these transformations, you can refer back to these t-tables. So on the parent graphs on these, I've already filled in your parent graph t-tables for you, and we'll look at how to adjust them when we have numbers thrown into our equation that change up our functions. So the first one is y equals x squared. So what type of graph is this? This is our parabola. And here's our parent graph, so let's graph that as a refresher so we can kind of have a baseline to see how our function has changed. Remember, that's our U-shaped graph. Don't make it look like a V because that's your absolute value graph. Okay, so now let's look and see what's changed with the equation. On this next one, it says y equals the value of x plus 2 squared. So here's our t-table we're going to use for those. And we're going to plug in some numbers in here. Let's start with negative 2, negative 1, and 0. See what else we need. So when you plug that in, negative 2 minus 2 is 0, and 0 squared is 0. Negative 1 plus 2 is going to be 1. And 1 squared is 1. 0 plus 2 is 2, and 2 squared is 4. Do you see how these numbers are getting bigger? we need to make some numbers smaller so we can get the other side of the parabola. So let's look at some numbers on our x values that are less than -2. So let's try -3 and -4. -3 plus 2 is -1, and -1 squared is 1. And -4 plus 2 is -2, and -2 squared is going to give us 4. So now we have some values to graph. And what happened to our parabola this time? It just shifted left 2. Notice the change of signs, because this is our negative part of the number line on the x values on our horizontal shifting, but this is a +2. So whenever you do a horizontal shift, we're going to take the opposite of the sign of the value. Okay? The third one is x squared plus 2. So we're going to use this t-table over here, and this time, because we are squaring and then adding 2, we can go back to our original parent values for our x values. So -2 squared is 4, and 4 plus 2 is 6. -1 squared is 1, plus 2 is 3. 0 squared is 0, plus 2 is 2. 1 squared plus 2 is 3, and 2 squared plus 2 is 6. Graph those. And what has happened to your equation this time? They have gone up to a vertical shift of 2. And keep in mind, this is your positive values on your y-axis, and this is +2. So this time we're going to follow the sign on our vertical shifts. All right. On number 2, what type of graph is this? Look at the square root sign. That should be a huge key for you. So our graph is our square root graph. And here's our parent value t-table again. Notice those positive numbers. And now let's look at our transformations on this one. So the first one is the square root of x, and then add 3 to that. So we're going to use our t-table here, square root of x, and then add 3. So we can use our same values on our t-table here. So the square root of 0 is 0, and then add 3. Square root of 1 is 1, plus 3 is 4. Square root of 4 is 2, plus 3 is 5. Graph those. And what happened this time? It went up 3. Are you starting to see a pattern? I hope so. All right, and our third graph on this example is the square root of x minus 3, and now the x minus 3 is all together underneath the square root sign. So we're going to have to put some numbers in our t-table here that are going to force this to be a perfect square and make these numbers easier to graph. So let's do 3, because 3 minus 3 is 0, and 0 does not get the negative sign. Let's try 4. 4 minus 3 is 1. Square root of 1 is -1 when you put that negative sign with it. And then 7 minus 3 is 4. The square root of that is 2, and then our negative sign makes that a -2. So what's going to happen here when you graph it? Now what happened? It has shifted right 3. Sorry, it's kind of hard to read. And what else has happened? These two were up in quadrant 1, and this one's down in quadrant 4. That negative sign has caused it to reflect which axis? The x-axis. So we've had two transformations together in the same equation here. So sometimes we can see stuff that runs together, not just one transformation in a function. Okay, number 3, we're going to look at the absolute value of x squared. So the graph type on this one is absolute value. Here's our parent function on our t-table, so let's graph those real quick so we can see what has happened with our transformations. Okay, so the first transformation we're going to look at is 1/3 times the absolute value of x. So when you do these, I'm going to put some numbers into our t-table that are going to be easy to divide 1/3 by, or multiply 1/3 by, which is the same thing as dividing by 3. So I'm going to try 6, 3, 0, -3, and -6. So the absolute value of 6 is 6, and multiply that times 1/3 and you get 2. 3 times 1/3 is 1. 0 times 1/3 is 0. -3 times, the absolute value of -3 times 1/3 is 1. And the absolute value of -6 times 1/3 is 2. So let's graph these. So what's happened to our absolute value function now? It has gotten much fatter. So we're going to call this a vertical compression, because we're going to kind of compress it and squish it. So fractions are going to make things fat. So think fractions. And that's going to help us remember that fractions are going to compress it and just kind of squish it out. And our third graph is the -2x, the absolute value of -2x, I'm sorry, the absolute value of 2x times -1. So we have negative absolute value of 2 times x. So let's go back to our regular parent function t-table. So the absolute value of -2 is 2. Multiply that times 2 and you get -4. And you end up getting -4 for your answer because of the negative on the outside. -2 times 1 is -2. And then we get the absolute value of that. And then 0. And then 1 times 2 is 2. And the negative sign makes that -2. And then 2 times 2 is 4, and we have a negative sign to make that -4. Go ahead and graph those. And now what's happened to our graph? This is going to be stretched vertically, standing up tall. A vertical stretch. It's kind of hard to read that. And what else has happened? It has reflected which axis? Good. Reflect the y-axis. So we've kind of got a lot going on in this problem. So let's review it. 1/3 times the absolute value of x is a vertical compression. think fractions make things fat. And then -1 times the absolute value of 2 times x makes this to be stretched vertically, and it's going to be reflected over the y-axis. Okay, number 4, what type of graph is this one? Look at your parent graph. It's a cubic because of that cubed here on the x value. So we have our parent function t-table already. So let's go ahead and graph those. Okay, this one's our little twist, our Don Travolta. And now let's look at the transformation on this one. The first one is going to be the -3 times x cubed. So we can go ahead and use our regular t-table for this because we're just going to multiply some numbers together, and we can do that. So we have -2 cubed, which is going to be -8 times -3 is +24. Be careful of your signs. We've got a lot going on here. -1 cubed is -1 times -3 is +3. And 0 times anything is 0. That's an easy one. 1 cubed is 1 times -3 equals -3. And 2 cubed is 8 times -3 is -24. So that's going to go off our graph, but that's okay. We can do that. So let's graph these. 24 is going to be way up here, so let's just go ahead and make a dot off of our plane here. -1, 1, 2, 3, 0, 0, +1, -3, and 2, 24. Make it down here. So this one's a little bit skinnier, standing up a little taller. So this is going to be our vertically stretched. Did we have any reflection going on? This time we reflected the y-axis. And then our third problem in this set is 1/2 times x cubed. So we're going to go over here on this t-table. And let's go ahead and use -2, -1, 0, 1, and 2. Okay. So we have -2 cubed, which is -8, and 1/2 of -8 is going to be -4. 1 cubed, -1 cubed is -1, times 1/2 is -1/2. And 0 times anything, our favorite is 0. 1 cubed is 1, times 1/2 is 1/2, and 2 cubed is 8, and half of 8 is 4. Go ahead and graph those. Okay, so this one ended up being compressed vertically. Good. Was there any x-axis or y-axis reflection in this one? No, there was not. There are no negative signs in this equation. Good job. All right, we're almost done. Let's finish strong. All right, number 5, we have a cube root here, so this is our cube root function. Here's our parent function that we did earlier. So go ahead and graph those. This is our surfer. Okay, now let's look and see what happened in these problems here. So your first one is going to be the cube root of x minus 2 right here. So let's try to use some numbers that go nicely into cube roots. That will help us with our graphing. So let's use -6, because I know that -6 minus 2, actually, yes, is -8. And the cube root of -8 is going to give us -2. And then how about +1? +1 minus 2 gives us -1. And the cube root of -1 is -1. +2 gives us 0. 3 minus 2 is 1. The cube root of 1 is 1. And how about 10 for our last one? 10 minus 2 is 8, and the cube root of 8 is 2. So let's go ahead and graph those. So what happened on this graph? It's a horizontal shift. Did we go left or right? So we went right 2. Notice our change in sign gets a -2, and we end up going right 2. Okay, and our last one is a cube root of -x. On this one, we can go back to our regular group of parent functions and t-table values. So be careful on your signs here. There's lots of negatives going on. -8 plugged in for -x gives us +8, and the cube root of that is 2. -1 into our -x gives us +1, so the cube root of +1 is 1. Cube root of 0 is 0. +1 plugged into our negative sign gives us -1, so our answer is going to be -1. And 8 plugged in is going to give us -8, and the cube root of that is -2. Go ahead and graph those. So what happened to your function? There was no shifting. All that happened was a reflection of the x-axis. And what caused that? Indeed, that was our negative sign underneath the square root. Good job. Alright, so let's step it up. I think you're ready. Let's look at a challenge problem. So we've got a lot going on here. We've got a -2 on the outside. We've got an x plus 2 underneath the absolute value bars here. And then you also have a -3 on the other side. So we've got 3 different transformations that are going to go on here. So if you kind of look back over your notes that we've done, we'll see that the -2 on the outside is going to do something similar to this. This one's stretched vertically. So we're going to have a vertical stretch in there, because we also had a -2 here and it got stretched. And then we have a +2 inside our absolute value bars. Well, here's a +2 in our parabola, and that's shifted left 2. And we also had a -3 on the outside. Well, there's a +2 was shifted up, so this is going to be our vertical shift on the outside on your challenge problem. So I'm going to show you a shortcut here that's really nice to use. If you'll remember on your absolute values, just like any angle, your absolute values are going to have a vertex, which is where your absolute value bar or your absolute value function comes to a point. So this vertex is going to be actually the movement of your horizontal and your vertical shifts. So your movement here, are these two things, and that's going to give us our vertex. Remember, take the opposite sign of what's inside, which is your horizontal shift. So we're going to go left 2, and then that -3 tells us to go down vertical 3. And I know that this is actually going to end up being my vertex of my absolute value graph. So I'm going to go left 2, down 3, and it's going to hit right there. So now we can ignore the rest of that equation, so just think about covering that up, and now all you have to deal with is -2 times the absolute value of x. So now you can make your t-table over that. So that's over here. We want -2 times the absolute value of x, because we've already moved our vertex, so we've taken care of these two things. So let's plug in some values here. We have -2, -1, 0, 1, and 2. So now we're ready to plug those in. Absolute value of -2 is 2 times -2 gives us -4. -1 inside your absolute value bars is 1 times -2 is -2. 0 times anything is 0. 1 times -2 gives us -2. And 2 times -2 is -4. Now the only trick you have to remember on this is you need to redraw your x and y axis at your new vertex. And we're going to count this as your ordered pair of 0, 0 right here. So now when you go in to plug your t-table in, you're going to count this as 0, 0. So you count these over. So this -2, -4, start here at 0, 0. -2, -4 is over here, because this is our new origin for our absolute value graph. Your next ordered pair is -1, -2, 0, 0, 1, -2, and 2, -4 is here. And now there is our stretched absolute value that has been moved left 2 and down 3. So what type of graph is it? Is absolute value. And you should have known that right off the bat because you had absolute value bars in your equation. Okay, so let's wrap this up and put it all together and kind of have a note sheet for us to refer back to when we look at this. So we've got an A value, a B value, a C value, and D value all wrapped up together in the same equation. So what do those things mean? Well, your A value is going to be your vertical stretch, stand up tall, or your compression. Big fractions make us fat. So if you have our vertical stretch and compression on your A value, that's the very first thing in any equation that you might see. Your B value is going to be your horizontal, because it's attached to your x. If you were to use a distributive property, you'd have B times x and B times C. So this is our horizontal. Horizontal stretch and compression. Your C is still attached to your x, so we're still looking at horizontal. But this is our horizontal movement. And then I want you to keep in mind here, this is going to be opposite of the sign you see. And then finally, your D value is going to be your vertical movement. And this one is going to follow the sign. Okay. So that kind of wraps all of those things together that we've been looking at for your functions. So now you have this ready to refer back to if you need to. There's one challenge problem left for you to do yourself. And then there's some questions for you to think about that you can submit. And if you get those right, there is a candy reward. And once you finish those things, I want you to log on to Socrative.com. We've worked with this before, so go to Socrative and enter the room name Flaucher and take the quiz that's launched. Y'all did great today. Thanks for being here.